Welcome back to part 3. In the first two parts, we learned how to make a basic Jenga game where we can, if we're very careful, push out some blocks. Careful. Pick up a block, drop it with the leap motion. And in part 3, we're going to try to pick up the blocks that are down on the ground, which right now they're just simply out of reach. It's not possible. And the way we're going to do this is we're going to use leap-specific gestures to be able to look at a block, and then we're going to use a little bit of magic that will have telekinetic control over the block, and we'll be able to place it remotely. And I believe that should be pretty complete in terms of Jenga. So let's get to it. So in order to be able to pick up a block from the ground, we need to know two things. One, that a block is on the ground, and two, actually let's clean this up really quickly before we do anything else. Drop if not. And graph. Whoop. And hop. Drop it not empty. And there. There. So the event graph is cleaned up. Now, there are two parts, like I said. One is we need to know what we're looking at. And to be able to do that, we should create a function just called look trace. We're going to make a ray cast. And a ray cast has to have, well actually, let's take a look. What a ray cast in Unreal Engine 4 is called a line trace. And you have a couple of options here. And we just want to do line trace it for objects. And you can see this is a pretty complicated piece, and we want to just, well, we want to be able to check for specific object types. So let's see what types we want. Well, we want dynamic types, and yeah, just dynamic objects. Everything else we ignore. And we're going to show a debug trace to see where this is going. Now, to do a trace, we actually need a start position and end position. And the start position needs to be a world location for both of these. So the start position in this case is going to be where we're looking. And the way you do this is that you get the camera, which isn't the same here, actually, but you get the camera, and we're going to get the location. That by itself is not good enough because the camera actually stays fixed, and then the Rift, at least as it's currently implemented, will add additional offsets. So if you want it to be 1-to-1, you also need to add in the location of the Rift. So what we need is position, and so get orientation and position from the head mounted display. But this isn't rotated. See, like this position you get is relative to your character. So you need to actually get your character rotation, get world rotation, and you need to rotate this vector by that rotation. And now we can add these two together, and we get our initial location. So we're taking the camera position and we're adding in the rotated position of that the Rift, or your head-mounted display, reports back as a start position. Now for the end position, we want to have a vector that points forward from this vector that we found. The way we do this is we will take that vector and just we are going to take this rotation, combine it with the head mount display orientation, and get a vector from that. Now this vector will point straight forward from where you're looking. We just need to, and it'll be normalized, but we need to have this, look a certain amount of distance. So about 20 meters seems reasonable. So this is a vector that looks forward 20 meters ahead, and we should add this to our start location. And that will be the endpoint. So now we have where we're looking and the endpoint. And now we should get some hit results. Now, because we do a debug type, we will actually see where this is happening. Now we just need some sort of, event for the trace. And one of the ways we can do this is by adding one of the leap specific gestures. Now, previously we were able to just use the input mapping, so we didn't have to add any additional things. We didn't have to make this more leap specific than it is. But this time around we're using leap specific functions, so we're going to have to actually add a leap controller and a leap event interface. Hit compile, and we're going to be using leap gestures. The way we do this is we're going to drag out the controller and just call enable gesture. Oh, we don't even need that controller because it's already targeted here. And just call that on begin play. And the way we can do this is we're going to enable the circle gesture. So the circle gesture will now cause the circle gesture event to get fired. And when that happens, we're going to make a look trace. A look trace. So now when we're looking, you will see that we just made a look trace there, a red one, and we need to just make another circle. And you can see that we're making traces. Now some of this is really difficult to see. And the head mount, not the head mount mode. So we're going to try this in VR. Let's play VR preview. Just bear with me. There. Alright, so whenever I'm looking somewhere, you should see that we're now making look traces whenever we're making the circle gesture. And does that look correct? That doesn't look correct. It looks like we have one rotation inversed. Alright, so what could this one be? Let's go into the look trace. We probably need to reverse these two. Now we're back in VR. Let's rotate the body more. Yeah. Looks like we're getting a perfect look trace. Alright. Now that we have a perfect loop trace, we need to do something with our results. So we're going to break our hit result and we're going to check what we hit. So we're going to cast it to a static mesh actor, and if it hits a static mesh actor, we need to, well, let's just print out block hit or something like that. So now, look at in the console, it's just there, and then we can and you can see that that's not working. Alright, so we should add one more thing in here to keep things pretty clean. We're going to add an interface called look interface, and that interface will actually do nothing. It's just simply to characterize our objects, and the way we're going to do this is by adding this look interface, and we're going to an actor interface. Saving and compile. Okay, and now we go look. Branch. Now we will know that we hit a block. World dynamic. This needs to be a physics body, not a world dynamic. But now we've also made sure with the look trace, and anytime you see a hit, you see that it hits that. But if we try to trace it across static objects, it will just ignore that because that trace is invalid, but it will hit our blocks. Now, for purposes of this demo, I don't want the I don't want this trace to be valid if the location is not on the floor, and we're gonna do something fairly ugly and just put a little, we want this to be on the floor, and so we're gonna look at a box that is roughly on the floor, and you know, it's the Z position 90, well, it's this one, it's 180, so maybe if it's below 180 we can call that, yeah, that seems about right. 180, 190, it's below 160, then it's a valid, then it's a floor object. And there are some cleaner ways of doing this, but for the purposes of this demo, that's what we're going to do. We're going to take the location, And we're gonna break it, and we're gonna check the Z, compare float. Let's put that away. We're gonna see, is that one smaller than 170? If it's smaller than 170, then we've got a floor block. And we're hitting, but it's not a floor block. We have to actually make some floor blocks, and there's no way I can look at them except in virtual reality right now. So now that we're in VR, let's put out our hands. Just push some things over so we get some things on the floor. And you can see that if we're looking up here now, and there, it's below, then we're good. But if it's not, it's not. So our look trace is now on the floor. The only thing we need to do at this point is to pick this up. And the way we're going to do this is rid of the trace one frame. The way we're going to do this is everything except the grabbing condition. We basically want all of this to remain valid. So what we need to do is make a new function called pickup if grabbing, and I'm going to go in here, grab this branch, and do this. And we need two things. One is the static mesh actor, and the other one is the location vector and location object, and we're going to pass those through. Static mesh actor. We pass those through and change the pickup, instead of pickup if empty, to pickup if grabbing. And we're going to get rid of this branch. And that's that. So if all of that is true, we're just going to pick up the empty block at the location. We're going to pick up the hit actor, cast to static mesh actor, and we got the location, we got the actor we want to pick up, everything else is as it's supposed to be. Alright, so if we wave on this, nothing's gonna happen. We can grab can grab the block, drop it. Something weird happened. There we go. Kind of works. Now you'll notice it's very hard to drop these blocks in the correct spot. So it was hard to drop these blocks in the correct spot, and the reason for that is that we need to take that object that we got and we need to set the velocity, the linear velocity, to 0. You know what, we can also set the velocity. And we can also set the angular velocity to 0. And this way, when you drop it, it will just fall straight down instead of taking in any of your things. It will drop straight down. So let's go over this function for a bit. It's a pretty complex function. Ideally, I would split this up into a trace and a hit. And we could do that. We'll just call it telekinesis. Telekinesis with a hit result. Hit. So the look trace should just return the hit result. And then this part belongs in the telekinesis part. And so we take our out hit and we need to go into look trace, add in the output, and just call it hit. And then there we go. So we got the return node, drop it out here, pull the hit, and then in the event graph we now have a nice split where we can go into the look trace, compile it, save it. Just do look trace here again. And the second part is the telekinesis. And the way I would do this actually is that we can get the radius from the circle gesture, and in order to make less amount of traces, we'll just only call this look trace and this telekinesis function when it's larger than a certain value. And in this case, the radius, if it's larger than, say, 15 centimeters, then we'll do the look trace, and as long as the look trace is good, we will do a telekinesis, and we check if it implements the look interface, and if it does, then if it's by the floor, then we get the static mesh actor. We let us know that we got a floor block hit. Let's bypass that. There's no need for this function anymore. And we pick it up if it's empty. And we set the linear and angular velocity to 0. And with that, we should be able to do a full Jenga demonstration. Let's give that a shot. So let's go over what we've done. We've used the Locomotion controller and the Oculus Rift headset to track our fingers in real time, and we can walk up to physical objects we've created and interact with them on a finger level of precision. We can go up to them and grab, say, a block and release it. Well, I didn't say release it good. And if we have a lot of patience, we can play with the Jenga stack here and just use our fingers to carefully pull out a block, maybe adjust the rest of the tower a little bit, and push that out a little. And there we go. So we got a block out, and now with a little bit of luck, let's make some big circle gestures. Uh-oh, I picked up with the wrong hand, but it should be behind me. There we go. That should be more doable. There we go. And then we can use telekinesis to hopefully put this block on top. And that's one block. So I hope you have learned a little bit about how to use the unofficial plugin and how to wrangle it to make it work for you, whether it is through input mapping, custom interfaces, or leap specific events. You can add a leap motion controller and the interface to whatever object that needs leap specific events, and they're multicast. So if we wanted to, we could actually drag out another character here, and if we play, you will see it copy your motions and things like that. It's kind of funny. With that in mind, there are definitely a few things missing out of this, but I'll leave that as an exercise for you to figure out. One of which is locomotion. How will you move around without the keyboard? Is there a good implementation for that doesn't make you sick in VR? Another one is obviously skinning and how to make this. Maybe you want to make a dominoes. Who knows? Possibilities are endless. What you see currently only works for the leap motion. Hopefully further down the line there will be a plugin which will combine inputs from several different hardware and give you a clean skeleton like this that you can work with to implement a game, ignoring really what hardware powers the input of that skeleton. But more on that later. I hope this has been useful, and catch you out there in the metaverse.